Good day, students. Once again, we are still in the topic of compound interest. And now I will be recording example 3.4, which I highlighted previously to be a very lovely example where we compare simple interest with compound interests at different rates compounded at different times. Now it says you wish to invest 1,000 for 2 years. And we know that the amount that we wish to invest, or the amount that we invest or we have now for investment, is a present value. So that one is very clear. Or when we speak of the simple interest, this will be A, which is amount invested, or principal amount, which is the terminology of the simple interest. But the terminology of the annuity, this is the present value, but it's the same number. The amount is invested for a period of 2 years, and we know that 2 years will be N. It does not matter either you are dealing with it from a simple interest point of view or from a compound interest point of view. N still remains the number of years the investment has been invested, or the amount has been invested. And they say, which of the following investment opportunities will you choose, or investment opportunity will you choose? So now we need to choose out of the 3 investment opportunity that are available. And the first one is 10% per annum simple interest. That means we invest 1,000 at 10% per annum at simple interest. And we know that when it comes to simple interest, interest is earned from the amount that was initially invested. That means interest is not added back to the capital so that the original amount will increase periodically. So the amount invested here does not increase periodically. And the second option of the investment is that 9% per annum compounded biannually. And we know that this is compound interest, where the original amount invested increases periodically, and the interest of the current period is greater than the interest of the previous period, because we earn interest both on capital and the interest of the previous period, where the interest is added back to the principal amount that we have invested. And another compound interest is at 8% per annum compounded quarterly. We need to highlight the fact that our compounds are different. This is biannually, meaning 2 times a year. This is 2 times a year. That means twice a year. Compounded quarterly, this is 4 times a year. That means interest will be added back to the principal amount that we had 4 times a year. So now that means if in the number B scenario, if the amount is invested for 2 years, then we need to say if it's 2 times a year, that means in year 1 it will be 2 times, in year 2 it will be 2 times. That means the interest will be compounded 4 times over the period of the investment. In the case where the interest is compounded 2 times a year, which is half yearly or biannually or 6 months, then now we said that will be 4 times. Then now we come to the last compound, where it says that is compounded quarterly, and we know that there are 4 quarters in a year, meaning the interest will be compounded 4 times a year. That means in year 1 it will be 4 times, and in year 2 it will be 4 times. That means over the period of 2 years, the interest will be compounded 8 times. So this is very important also to highlight. And I would just want to bypass this, although I will deal with it mostly in example 3.6. We have a period of 2 years. I want to align that 2 years with number C. We know that 2 years is 24 months, and I did highlight this in passing in the previous example, which was 3.3. Then now, if we are given N as 24 months, we don't have to worry about converting it to 12 months. We can say, okay, if our N is 24 months, then now we can say, oh, we can divide this by the number of months in a compounding period. In the case of a quarter, we say in a quarter we have how many months? A quarter is 3 months. So now we need to say how many 3 months or how many quarters do we have in 24 months. And if you say 24 divided by 3, I think this should give you 8. If you say 24 divided by 3, this will give you 8, meaning it will be 8 compounds, same as I did with the previous one. And again, when it comes to number B, where it's compounded biannually, and we say our year, which is 2 years, is 24 months, then we can say now if you want to convert from the number of months to the number of compounds over the period of the number of months, which is 24 months, we need to divide by the number of months in a compounding period. Remember, if it's biannually, meaning it's half a year is 6 months, then how many months do we have in 6 months? It is 6 months, so we'll divide by 6. Therefore now this will give us 4 number of compounds over the period of 24 months, which is the same as 2 years times by 2 compounds a year. That is still giving us 4. And same applies here. We said 2 years times by 4 number of compounds quarters in a year, which gives us 8. So I want you to master this conversion both from the number of months and also from the number of years that can be provided to you. Now we need to take a decision in terms of the investments that will give us the better return. And I will have these 3, which is A and B and C. We need to know the sum accumulated, and we know that sum accumulated from simple interest, it is the amount invested is to 1 plus the interest times by n. So now our amount that was invested is an amount of 1,000, and plus 1 plus our I, it is 0.10 times by n. Our n is 2. So now that means the amount that will be there at the end of the period of 2 years will be 1,000, open brackets, 1 plus 0.10 times by 2, close our brackets. Then this will give us, 1,000 times 1,000 times open brackets 1 plus 0.10 times by 2, which is the number of years. This will give us 1,200 rands. So now this will be sum accumulated or the future value in the case of simple interest. Now let's go to compound interest. Compound interest, we need to say plus minus is an amount of 1,000. What is 1,000? 1,000 is the present value. Then we say our interest, it is 9.5% divided by 2, which is the number of compounds in a year, which is biannually, half yearly, meaning 2 times a year. Then this will be our interest. Then we say our n will be 2 times by the number of compounds in a year, which is again 2. Then our n, meaning in other words, will be 4. Then what are we looking for? We want to know how much will be the value of the investment after 2 years using the compound interest. Don't forget once again to clear your calculator at all times. Clearing the calculator, what does it mean? It means you say second function alpha 0, 0, you clear the memory. Plus minus 1,000 is the present value. 9.5 divided by 2 is the interest. You press interest. And 2 times 2, you press n. Then after you say compute future value. We can see that the future value, it is 1,203 rand 97 cents. And you can see that this investment has more return in comparison with the investment at simple interest. And at this moment, we can decide to say we opt for the investment that has a lower interest rate, but because of the number of compounds that are more frequent than simple interest, that are more frequent, not than simple interest, because in simple interest there's no compound. Because of the frequency of compounds, or because of the compound interest, then we can say that there's a better return. But let us look at the last investment, where the percentage, it is less than other percentage, but the frequency of compound, it is quarterly, meaning there are many times in which the interest will be compounded, or there are many times in which the interest will be added back to the capital, or it means there are 4 times in a year in which the interest will be added back to the capital or the principal or original amount that we have invested. So now that means we have to say plus minus present value of 1000, 1000 being our PV, and we say we have interest of 8% divided by 4. Don't forget how many times quarterly, how many quarters in a year? There are 4 quarters in a year. So always your interest as a full amount must be divided by the number of compounds in a year. So that will be our interest I divided by y. Then after we go now to our n, and our n, it is 2 years, and we say 2 must be multiplied by the number of compounds in a year. Then we say 2 times by 4, that means our n will be 8 in other words. Therefore now this will be our n. Then what are we required to calculate? We are required to calculate, or what we need to calculate, the future value. We need to know how much will be the value of this investment at the end of 2 years if it is earning interest at 8% per annum compounded quarterly, meaning 4 times a year. So now we have to say plus minus 1000 is our present value, 8 over 4 is our interest, meaning 8 over 4 you press I, then after we say 2 times 2 we press n, then we say compute future value, and our future value it is 1082 rand, 1082 rands, 1082 rands. So now that will be, okay, let me just verify, that is, we have 1000 plus minus 1000 present value, and we have 8 divided by 4 is our interest, and we have 2 times by 4 is our n, and we compute our future value. Then our future value, sorry, that is not correct, that is 1171 rand 66 cents. So now this is the value of the investment at 8% per annum compounded quarterly, and it's 1000 that was invested. And we can say that although the interest rate is less, but because of the frequency of compound in a year, we can say that we end up earning a higher interest or having the bigger amount at the end of the period of 2 years, because for every 3 months we get interest, we add it to the capital, and every 3 months we get interest, we add it back to the balance we had at the beginning of the period. So now this is very important to take decision and say the investment that we must choose is the investment at 8% per annum compounded quarterly, because the future value of 1171, yes, 1171, sorry for that, 1171.66 is greater than the future value of the other 2 investments, the one at simple interest and the one at 9.5% per annum compounded biannually. So guys, with that, it's very important to highlight that. Remember at the same time that we could have used the formula once again in the calculation of the future value, where we could have said sum accumulated is equal to A, which is 1000, brackets 1 plus 0.095 divide by 2, all to the power of 2 times by 2. So that could have been the same way to calculate your future value. Similarly, with the second scenario, sum accumulated, which we know that sum accumulated is the future value. You could have done that, you could have got to the same amounts without using the functions of the calculator. Whenever you're required to calculate the future value and present value, even the interest and even n, you can still use the formula. That can be another way, probably if you don't have the calculator, but it's also very important to master such. With that, guys, being said, allow me to say thank you very much. I will be then recording the last one example 3.5. Before I go and do example 3.6 from number A up to number D, but so far you can look at 3.5 and take note of in 3.5 that what are we required to do? We are required to calculate the present value. What must be invested presently to give an amount of 778.65 in 2 and 3 quarters, 2 years and 3 quarters at 6.8% per annum compounded quarterly. That means now we are looking for the present value. Or if you use the formula, we can say sum accumulated is equal to A into 1 plus 0.068 divided by 4, because quarterly there are 4 quarters in a year, into how many? 2.75 times by 4. I will explain the 2.75 to you later on, how to convert that 3 quarters, which is 3 over 4. 3 over 4 will give you 0.75. Then you say plus 2, then that give you 2.75, meaning it is 2 years and 9 months in simple terms. But I'll deal with that later on. In this case, we do have the future value, we do have the interest and everything. What are we looking for? We are looking for the present value, which is A, the amount that must be invested presently. With that, guys, I've prepared you for the next example. Let me say thank you very much once again. Stay well and stay safe. God be with you.